All right, this is lesson 5.6. We're talking about graphing linear inequalities. Linear means, again, that the equations are in the form y equals mx plus b. You can skip this page. We're not going to do this one. That's the wrong problems. So there's 3 steps when you graph linear inequalities. Number 1 is you graph the boundary. You're going to use a dashed line when the inequality contains greater than or less than. And then when it's less than equal to or greater than equal to, you're going to use a solid line. So in other words, if you see y is greater than or equal to mx plus b, then this is going to be a solid line when you graph it. If it's y is greater than mx plus b, then this is going to be a dashed line when you graph these. So that's the first step, is determine what does the line look like. Step number 2, use a test point to determine which half plane should be shaded. So the solution to these inequalities like this are all the points that are above or below these lines. There's another thing you ought to know, and that's that today's lesson is graphing linear inequalities on the coordinate plane and solving inequalities by graphing. By the time you're done with this, you should at least be familiar with these words: half plane, boundary, closed half plane, and open half plane. We're going to skip the warm-up. There are 3 steps to graphing linear inequalities. A linear equation is y equals mx plus b form in slope-intercept form. Okay, this is an equation. An inequality will have, instead of y is greater than or equal to, or it could have a y is greater than mx plus b, and you could have y is less than or equal to, and y is less than. So the solutions to these are half plane. So you need to know that you're going to use a solid line to graph a line. First, you're going to graph a boundary line when the inequality contains less than equal to or greater than equal to. And then the dashed line is important when the inequality contains greater than, less than, or greater than. Step 2 is you're going to use a test point to decide which half plane should be shaded. And the reason here is like this. If y is greater than or equal to, and say there's an equation like this. If y is greater than, all the points above this line are all part of the set of the solution for this inequality, so every single one of these points. So we call this a half plane because we're going to shade just the half plane, and we draw lines like that. So if I had an equation that was y is less than or equal to, say, 3x plus 1, my boundary is going to be something like this. Y is 1. Go up 3 over 1, solid boundary, and this is all the y values that are less than that line. So we would shade on this side, and I'll show you how to do that with a test point too to decide that. Okay, so here's an example. We're going to graph y equal, or 2y minus x, 2y minus 4x is greater than 6. First things, we'll solve for y in terms of x. So we're going to add 4x to both sides. You get 2y is greater than 4x plus 6. Then you divide by 2. So y is greater than 2x plus 3. Okay, so this is a greater than, it's a dashed line. So we're going to graph y equals 3 as our first point, then go up 2 over 1. Connect the dots. You can add as many dots as you need to make a straighter line. And this is a solid line that I drew on here. So this is not what we wanted. We want a dashed line on this. So we need to change it. But that's what the line would look like if it were the equation graph. So we're going to go and change this to just a dashed line because it's a dashed, no line underneath. So you go and graph it like this. Then you have to decide where all the points are to go with this inequality. Are they above the line? Are they below them? Well, the easiest way is to pick a test point. If 0, 0 is available on either side of it, so the boundary line isn't crossing it, 0, 0 is a great test point. We're going to stick it into the inequality. You can stick it into either the original one or the one that's y, the y equals mx plus b format. So I'm going to put it into this. When I put the 0 in, I end up, when I simplify that, with 0 is greater than 3. And is that true? Because if it's true, then that's the side we shade. But it's not true. This is a false thing. So we're going to shade the other side. So all the points that make the inequality true are all over on that side. And if you want to check one, you can go and check one real quick. Just take negative 2, 2, and we'll put it into the inequality. So is 2, because we're using the negative 2 point, is 2 greater than 2 times negative 2 plus 3? So is 2 greater than negative 4 plus 3? Is 2 greater than negative 1? Yep. So we've got the true side shaded. So any point over on that side would work. Any point on the other side is going to make the inequality false. So let's do this a little quicker. Graph this one. So move the x to the other side. Remember, there's a 1 in front of the x, so y is greater than or equal to negative 1/4 x plus 1/2. This is going to be a solid line. It's going to have a y-intercept of 1/2. I'm going to go down 1 over 4. 1, 2, 3, 4. And again, I went down because that's a negative slope. So I'm going to draw the line. This is a solid one. So there's my line. And now we'd use the test point. So 0, 0 is the best test point. The math's easy. Is 0 plus 4 times 0 greater than or equal to 2? So that would be 0 is greater than or equal to 2. So that's false. So we're going to shade above. So to write an inequality, now I have to go backwards. First thing, you have to find the equation. We're given the graph. What does solid mean? It means, well, y is greater than or equal to, or y is less than or equal to. The equation of this line, though, if you remember the Hoy-Vux, horizontal 0, y equals, vertical undefined x equals. This is an x equals equation. X equals 2. So for this one, it works the same way. It's going to be x is greater than or equal to, or x is less than or equal to. So if we look, 0, 0 is in the shaded region. And if x, this is x equals 2. So now I have to decide, is it x is greater than or equal to 2? Or is x less than or equal to 2? The true inequality when we stick in x equals 0. Well, it doesn't work for that one, right? But it works for this one. So this is x is less than or equal to 2. So this one again, Hoy-Vux. This is the Hoy part, horizontal 0 slope y equals. This is y equals 1, 2, 3, 4. This is going to be y is greater than or y is less than 4. So we have to figure out which one is true. So there's our test point, 0, 0. So 0 greater than 4, or is 0 less than 4? And this is the one. So y is less than 4 is the inequality. And then we have some word problems. You have to translate the word problems into inequalities. So to do this one, read the question. Reagan writes and edits. So there's always two variables going on with this. There's the writing. So I'm going to say W equals the time that he writes. oh, sorry, the number of articles. I need to read the whole thing here. So he says it takes him about an hour to write an article and about half hour to edit an article. So we want to find out how many articles. So to write, this is the number of articles written. Let's change that to x. We're defining the variable, so define y to be the number of articles edited. It says it takes him about an hour to write an article. So he's either writing articles or he's editing, right? And it takes about half an hour to edit an article. So if he works up to 8 hours a day, so that means he's not going to work above 8 hours, but he could work 8 hours. Then we have to figure out the equation that goes with this. So it's 1 hour to write an article. So 1 hour times the number of articles written plus half hour to edit, so 1/2, times the number of articles edited is less than or equal to 8. And if we wanted to put that in standard form, we multiply everything by 2. And there it would be in standard form. Okay, this one, we're either buying chicken sandwiches or buying tuna sandwiches. I'm going to say C equals the number of chicken sandwiches bought and T equals the number of tuna sandwiches bought. You have up to $30 to spend. So the number of chicken, the cost of the chicken can't be above $30. So our inequality is going to look like this. The total cost. Okay, so the total cost includes $3 for every chicken sandwich. So $3 times the number of chicken sandwiches bought plus $1.50 times the number of tuna sandwiches bought must be less than or equal to $30. So that would be the inequality for that one. You have bookwork to do. It should be on the board. It also is in your lap. It's in the OneNote. All right. Do your work. Bye.